It's just rolled over to the afternoon, so good afternoon to all of you joining us. If you'd like to let us know where you're sitting today, where you're from, please do feel free to use the chat button. For those of you who are familiar, we are going to be using Slido today, so you can download that in one of two ways. You can go to the QR code and put your QR reader on, or you can go to slido.com and enter today's code, which is LM200522. For those of you familiar, the poll's already up, so if you want to start filling that in, please do so. I'm going to wait another couple of minutes. We are expecting more, so I'll tell you how we're going to be using Slido. Besides an opening poll, we're also going to be using it as we normally do for your questions and answers. So if you have any questions for Charles, could you please put those into Slido in the Q&A section? And if you think that's a good question that someone's asked, you can always thumb it up, and the more thumbs up means that question goes to the top of the list. We will be using Slido at the end of today's session. I'm going to run through it in the last couple of minutes. So please do give your feedback, as it's a way we learn and understand how we can move forward with these sessions. So we've got a number of people in, so I think rather than just sit around and wait, so let's put the poll up, please, Abraham, and let's go through that. So the first question we have, with a move to net zero carbon buildings, how much timber do you think you will be using in your projects? It's simple, you make one choice, a lot more, about the same, or less. So please make a choice of one. 4 people have already answered the complete poll, which you'll see from the top, but not to worry. Second question. What do you think is the current net annual loss of forests worldwide? 47,000 hectares, 470,000 hectares, 4.7 million hectares, or 47 million hectares? Well, that's a wide choice. So what do you think is the current net annual loss of forests worldwide? Okay, let's move on to the third question. What percentage of waste timber do you believe is currently recycled into other construction materials, e.g. chipboard? 10%, 20%, 30%, 40, or 50? Okay, let's have the fourth question. What is your understanding of the principles of the circular economy? Very good, good, limited, or none? So if you can make one of those 4 choices, thanks very much. And let's move on to the last question. How confident would you be in incorporating circular design principle into your projects? Very confident, somewhat confident, or not confident? So 14 of you have kindly filled in the questionnaire. Don't worry, if you'd like to continue to fill it in, please do so. As you'll see, it's live and things will change as you give feedback. So I think what we'll do, Abraham, let's please go back now, and with Charles, we'll go through the actual poll results. So with the move to net zero carbon buildings, how much timber do you think you will be using in your projects? Well, half the audience think more, about the same 36%, and a lot more 14. Interestingly, no one's chosen less. So Charles, how does this fit with normal feedback you get?
Well, we don't usually ask this question, so it's good to see. It's the first time I've asked this one, so it's interesting. With the move to net zero buildings, I think we're going to need to have to use a lot more timber, timber frame, moving away from concrete and steel and moving on to use of more timber frame structures. I suppose it very much depends on the type of project. Some people might be using a lot of timber frame at the moment, so in which case they might carry on using about the same. But it's good. It's good to see that there's quite a number there that are going to use more or a lot more. So it's good to see.
Okay, super. Thanks very much. Abraham, for question 2, what do you think is the current net annual loss of forests worldwide? 4.7 million hectares. Oh, I'd like to say I got that right. That's still a hell of a lot.
That is correct. 4.7 million hectares. Obviously, maybe some of the people saw the last responsible sourcing webinar where we had that figure in there. So hopefully people have remembered that. But that's the right answer. 4.7 million hectares. So that's good to hear.
Yeah, I mean, it's just hard to imagine how much land that is, or how much forest is actually.
I think there's something in there where I talk about. I think we've lost in the last 10 or 20 years an area the size of Libya. On forest, which is quite a big area. So,
and that's interesting comparison because that was the wheat fields of Rome.
Yeah.
So, next question: what percentage of waste timber do you believe is currently recycled into other construction materials, e.g., chipboard? 10%, 40%. Yeah. What do you think? Yeah. Have people got that right, or are we going to wait for the answer?
The answer is actually nearer 20, and we'll look at where the rest of it goes as part of the presentation. So, good to a big mix there. A lot of variation there into what people think is actually happening at the moment, which is understandable. So, there's no right or wrong answer to any of these. Absolutely, obviously. So, in a lot of cases.
So, 60% of the room have a good understanding of the principles of the circular economy. 40% have a limited. So let's hope we can improve the good and certainly totally fill up the learning with the limited.
Absolutely. Sounds good.
Is that the sort of normal that you have in a room for these kind of sessions?
Yeah, I think, people have got, a lot of people are starting to understand it a bit more, but others are very much on the start of the journey. So let's hope we can try and explain some of the principles. So we will spend a little bit of time on that at the beginning, on what we think the principles are. So that's good.
How confident would you be in incorporating circular design principle into your project? 50% somewhat, only 20% very, and 30% not.
Yeah.
I think that's a topic you're going to cover.
Well, exactly. We'll hopefully be able to give you some ideas on how you might be able to incorporate more circular initiatives using timber. We've got quite a few examples and suggestions coming up, so hopefully we'll be able to help you there, which is great. Good.
Okay, thanks very much, Charles. I'm going to hand over to you.
Thanks, Howard.
I'll just remind people, if you have any questions, please do use Q&A in Slido. Many thanks.
Okay. Good. So hopefully you can all see my slides now. So all good.
Yeah, I can see that fine.
Yeah, all good. Thanks, Howard, for confirming. Right, brilliant. So timber and the circular economy. We've obviously discussed a lot of this. What we're going to cover today quickly is what is the circular economy. So we'll explain that, answer that question for you. Explain how timber fits into that, and how responsible sourcing of timber is part of that journey. And then we'll spend quite a bit of time on how you might be able to design in timber for a circular economy, and then some of the business models that we might need to adopt to make that happen. Obviously, at the end of this session, hopefully you'll have a better understanding. You guys will get CPD certificates, or can do, via the Leaders Meet session. So this goes straight in. And what is the circular economy? So back when I started in the industry, there wasn't such a thing as, it was never thought about circular economy. We just had this, what we call our, consumer model, where we take stuff out of the ground, we make stuff with it, and then dispose of it in skips. But, and that has resulted in a hell of a lot of waste. This is, a diagrammatical explanation of that. So this is the process of materials at the moment. They, take, make, dispose. Most of that goes off-site as waste in the various different parts of the supply chain. That currently ends up going through what we call a materials recovery facility, or a MRF. A fair proportion of that goes in construction industry. Maybe a certain amount gets reused, but that's generally the heavy stuff. And when I say reused, that's probably downcycled into things like aggregates. And around sort of 3.7 million tons ends up in landfill, and this is the last figures we got from DEFRA, because that's the last time they actually funded a study into C&D waste, was 2014. So unfortunately these figures are quite old, but they may have improved slightly since then. But as I say, DEFRA haven't funded any further research in this. Now the problem is we see a fair bit being diverted from landfill, but the trouble is up to half of that is actually going into energy recovery and waste. A lot of the remainder is going to what we call open loop recycling. So there's no defined end use for that decided at the beginning. It's just, well, we've got some plastic or we've got some steel, we'll recycle that into something else, rather than being a closed loop model. And that's so very little waste is going in through a closed loop model, and that's really where we need to get to really reach the circular economy. And this is explained in this diagram, which was produced by a guy called Walter Stahl, now Professor Walter Stahl, back in 1981, and he's still around. I bump into him every now and then at some trade shows. But he came up with this, sort of first idea of these loops, where you've got different materials moving around the loops and being reused in different phases before they get disposed. And that was improved upon by people like McDonough and Braungart, who developed their cradle-to-cradle standard in 2010. And also around the same time, you had the Ellen MacArthur Foundation came up with their butterfly diagram. And both of these sort of introduced this idea of these biological and technical nutrients, which on the face of it seemed like a good idea. You've got your technical nutrients, which they talk about steel and stuff like that, which you maintain and reuse, redistribute, refurbish or remanufacture, and trying to keep it into the inner loops here is the best option. And then you've got our biological materials, which, to be fair, timber would fit into, where we say, where we cascade recycle it and then it goes into the biosphere and goes back into the earth. But my view on this is actually timber sort of straddles both of these items, because especially when you start talking about engineered products like CLT and glulam, we very much need to make sure we keep them in this technical nutrient side before they end up in this cascading model. Obviously, the key thing in this model that it talks about at the bottom here is that we need to minimize the material being lost from that cycle. So anything being burnt or landfilled, we need to keep to an absolute minimum. So I've tried to then redefine this as how we could do this within the construction industry. So we've got our raw materials coming in, and we've got timber and aggregates, and we've got our oil-based products such as plastic, which we're going to need to try and design out going forward, because it's just not going to be there. Our production facilities, we need to start moving over to more renewable energy systems to power those. We need to look at the business model of how we're going to actually sell our products into the market. And, where we sell things now, we're starting to see, things around leases and service models starting to come into the industry, which we might be the better option for our business. So we see that with cars at the moment. 20 years ago, we've all bought our own cars. Nowadays, we're more, a lot of people are actually leasing cars rather than buying them. So that's an option we've got to look at. We then install that product, and as part of that process of the manufacturing and installation, we're going to get some waste, which we need to try and make sure we recycle back into the system. We then get our installed product going into our building, and we're going to use it. We need to make sure we maintain it to keep it in service for as long as possible, and trying to keep that product in use. But obviously, it will come to the end of its service life at some point, and we need to try and make sure we deconstruct it. It's deconstructible. We can then disassemble the product itself into these different component parts, and each of those component parts might then be able to be reused. Where they can't be reused, they might go back to the factory and be refurbished or remanufactured. And as a last resort, we should be really looking at recycling. We talk about recycling being really good at the moment, but actually in the circular economy, that is the last resort. We need to think of all these other options first. And if we do that, we can then reduce that requirement on that raw material. And that is a finite resource, especially, we talk about timber and being renewable, but there is only so much out there that we can use at any one time. So to a point, it is a finite resource. So that will reduce our need on that. And anything being lost out of that cycle, we need to make sure we've got some defined usage for it. So that's sort of the model we're going to be focused on today, and how do we move forward with that. So focusing on timber specifically, this is a diagram that was produced by CEI Bois, which is the European Timber Industry Federation, and it sort of showed some sort of how timber moved around the system. And I've actually added to this because there wasn't enough hours on it for me to try and actually say what's actually happening with all this material at the moment. So we've got a very small amount going to landfill. Timber, actually, less than 1% of timber waste goes to landfill at the moment, which is great. Just to put some numbers on that, the vast majority, though, is very much going into energy recovery, biomass market, and that's, to me, is not the right thing we should be doing on certain bits of timber at the moment. We talked about our 20% being recycled into panel boards or insulation, and another 10% is going into animal bedding. But if you look at those, all of those apart from the panel boards are short-term products. So that carbon that's been pulled out of the atmosphere by those trees is very much, disappearing after a short amount of time, and it's only the panel boards that's keeping that carbon locked up. So where we could be doing a lot more with that. We start looking at the maintenance and reuse and remanufacture elements, and we really don't know what's happening with that market at the moment. There is no data on that at the moment. But like I say, for me, we need to look at that recovery model. And like we said, we're getting ever increasing demand for timber. A lot of you have said that you're going to probably be using more timber in your projects going forward. So where is that going to come from? So we need to think of different ways of using timber and using different types of product that have the same end result, but maybe by using different types of materials and being more resource efficient with that material going forward. So just to put some numbers on where with timber, you would have seen these if you was at the responsible timber sourcing one the other week. Most of the stuff we import is softwood. It's about 16 million cubic meters a year, with a certain amount of particle board and fibre board, which are all made from softwood products, with the remainder being hardwood, sawn hardwood or finished hardwood products, and hardwood or in some cases softwood plywoods. So that's the breakdown of the material that we're using. On average, most years it's probably around nearer to 17 million. This was obviously 2020, the pandemic year, so there was a slight drop there. But usually you're looking at around 17 million cubic meters of timber. Now, when you start looking at where that comes from, obviously, most of that is actually coming from a reasonable, secure sources. So the UK, a large percentage there, vast majority coming from the EU. But then you start to see certain bits coming from places like, Russia, which is now gone. We've stopped all imports of timber from Russia, and there was 500,000 cubic meters of timber coming in just from Russia, and now that's got to be found from somewhere else. So there are issues around security of supply. And when we start looking at, the Institute for Economics and Peace, their peace maps, we look at Russia and Ukraine there being, very much an issue of source security, and that is now stopped. That is now gone. Europe, luckily, is fairly stable, so we shouldn't see too many issues with those timber supplies. But everyone's obviously after the same timber at the moment. We talked about the amount of timber that's being lost, and yes, it is that 4.7 million hectares. That has gone down since the 90s, when it was probably at its peak when we first started looking at this. But when we start looking at where that's from, obviously we start looking at things like South America, Sub-Saharan Africa, and the Far East. Are the sort of where we're losing most of that resource. Luckily, again, most of the stuff we're getting from, or near enough all the stuff we're getting from Europe is generally going to be responsibly sourced, and we're not, at the moment, impacting on that deforestation. But as you can see, there's a lot of countries there in Europe which are very much on the grey area, where it's just finely balanced. And if we start using a lot more timber, could that start to tip into a net loss? And that's what we've got to be careful of going forward. As far as drivers for the circular economy, you've got things like BREEAM. I'm actually on a working group with BREEAM at the moment to see how we can include more circular economy measures within the BREEAM. There are some at the moment around waste and things, but that's only going to increase. And SCAR is probably the one that's probably got the most circular economy requirements in it. So this is coming, and we are going to have to do it. So how do we do this? Well, firstly, if we're going to be using timber, we need to make sure it's responsibly sourced. I think that's the first thing. Timber is a circular economy material already. If you're getting it from a sustainable source, we are replanting trees, and we're always going to have that resource if we use it efficiently. So the first thing is looking at sustainable forest management. There's two ways that's done. If you saw our presentation last time, you generally have your softwood forests, which are planted in effect as a crop. They're allowed to grow, they're thinned out, and different products are taken out at different times. But at the end of the day, those trees will be clear felled, used for structural timber purposes, and that area of land will be replanted for new timber. And that cycle, depending on where you are in the world, in the UK, it might be 35, 40 years. In Scandinavia, it might be 70, 80 years. So, it's a cycle, and it's a long-term crop in the same way, and that's how we need to treat timber. That's how we need to think of it in that situation. Hardwood, slightly different, generally done by what we call selective felling, where we take out logs from an area of forest, but only an amount that can be regenerated in a certain amount of time. So we make sure we've got that regeneration over that growth cycle of maybe 100, 150, 200 years in some cases for some hardwood timbers. Obviously, this is a requirement for many customers, not least the government, and a lot of companies have adopted similar policies where they'll only accept timber from legal and sustainable sources, need to have appropriate documentation, and that applies to all virgin timber and wood derived products not used on the government estates, including temporary site work. So, we need to make sure we think about things like hoardings and shuttering timber and any protection that you might use. A lot of timber is used in those elements on certain sites. So we need to make sure we include that in there. And basically what the government has said is that you need to make sure you comply with one of these, with their central point of expertise on timber. So you have to gather evidence either from independent forest certification schemes, such as PEFC, the Programme for the Endorsement of Forest Certification, who are actually sponsoring today's event, FSC, the Forest Stewardship Council, or Grown in Britain, although that's in the category B evidence at the moment. That's likely to move into the Forest Certification Scheme when they update this. So, as a UK forestry source. So that's our best way and easiest way of ensuring that our timber has come from that responsible sourcing. And like I say, if you want to learn a bit more about responsible sourcing and how you can track that, if you wasn't on our last course, look at the PEFC website and you can sign up to one of their responsible timber sourcing CPDs that we do on there. Just to, obviously, where does that responsible source timber come from? There's a lot of countries in the world now that are sourcing that have got forest certified to one of the two standards, PEFC or FSC. And you can see that Europe, actually, most of the forests in Europe and North America are actually certified against one of the PEFC type schemes. FSC is generally concentrated on the high risk areas, such as sort of the South America, Africa, Far East, and obviously Russia. So what we're saying is one scheme isn't better than the other. There's no better scheme, but just make sure that you don't just choose one scheme, because there are some companies out there that say, oh, it must be FSC timber. But if you look at this, actually that could cause an issue with your supply, because you're very much limiting where you can get your timber from, your FSC timber from, if you just specify FSC. And you may come in, especially the situation at the moment where there is a shortage of timber, you might not get what you want. So moving into designing for circular economy. For me, what I've generally broken this down to is 6 main areas. So we need to design for resource optimization. I'll explain all these as we go through. Design for low embodied carbon. We need design for optimum service life, ease of maintenance, flexibility, deconstruction, disassembly, and then remanufacture and reuse. So we'll cover each one of these in turn as we go through and explain them. I won't explain them now. So designing for resource optimization, this can mean a number of things, really. And the first one is you make the best use of the existing resource available on the site. So if we've got an existing building there or an existing structure, should we actually reuse that rather than knocking it down and building new? So that's sort of the first thing. Let's make do a pre-demolition audit of the site, look at how what's there, and can we actually reuse most of that, if not all of that structure, in our new build. The next bit is then we need to make sure we use the best use of the resources from the forest as well. So that's another way with timber. So rather than just using lengths of timber, which we may have done, I say 60, 70 years ago, we would have chopped a tree down and maybe only got 50, 60% of the wood out of that timber, because obviously we want to change a round item into a square item or a rectangular item section. So there's obviously going to be a certain amount that's lost out of that. And obviously, when the tree's growing, we thin certain trees out that are in the way of the good ones that are growing. What happened to those? And actually what happens now is things like OSB, orientating strand board, you might know it's sterling board or smart ply, that's made of those thinned materials. So we're making a much better use of the resource. And obviously the stuff that we're cutting off, we might be using some of that for pallet wood on the falling boards on the side. The chip and the sword material is going into things like chipboard. So, via a co-product, from the primary processing. So we're making much better use of that round log, where it was in the past we might have only used certain parts of it. The next bit then is, so we've made the best use of the resource from the forest, but are we actually making the best use of the resource brought to site? So, in that situation, it's about minimizing offcuts, minimizing waste on site, so designing to standard product dimensions to reduce waste, off-site construction, so we can utilize a lot more of the material. So those are the sorts of ideas that we might need to think about there. And just to give you some examples, this is the Aleander HQ in the Netherlands. You see a lot of examples from the Netherlands on circular economy. They're doing a lot here. And this was their original building. They wanted to redevelop this, and they brought the architect in, Thomas Rau, and said, "Look, we're thinking of knocking all this down and starting again." And Thomas Rau said, "Well, actually, we're not that sort of architect. We're going to come up with a design that can utilise a lot of these new buildings." And what they've done is repurpose all those buildings and reclad them, re-insulated them, used in certain places. These are actually the repurpose. This is actually pallet wood from waste pallets that they've used internally as a cladding material. So, and what they've ended up with is this building inside. So this is the pallet wood on the left-hand side here, and on the right over here internally, obviously, because it's not treated. But that's what the internal artist's impression was, and that's the actual picture of the completed building. So all of these bits that are poking out the sides, they are those original horrible looking concrete buildings that we saw in the original picture, turned into a lovely open plan office environment. So you can make much better use of existing buildings if we think laterally. Talking about how we can use better resource from the forest, we talked about OSB. This is OSB, and there's lots of different types of product that this can be used for now. You can use it as flooring or as a sheet roofing material, as many people may know. But also for things like, they've got lots of different sort of sub-projects, products associated with that. So things like Sterling board have got their Strong Fix, which is, it can be used for mattresses within stud walling systems, for example. Or Smart Ply have got their Pro Passive, which means, which is an air sealed board, which you just have to tape the joints on to create a passive house structure. So, much more, so many more different products now that are being made out of things like Smart Ply, and make much better use of that material from the forest. You've also got engineered products like these are I-joists from Metzer, where they've got an OSB web in the middle there, with a plywood or LVL top and bottom to them. So, again, we use it rather than using solid bits of timber that we may have used in the past to make a large joist. We're now using much smaller bits of timber, much less timber in that product, made from a much more renewable resource, because we're using all the offcuts from that would have been skipped 20, 30, 40 years ago, and we're now making a much better product that's actually much stronger than the original piece of timber that we might have used. LVL is another similar example, where you've got these long beams that look like plywood. And then we need to look at other products as well, that where we might use timber for at the moment, could we use other crop materials, so short rotation crop products like bamboo and hemp, so hemp blocks that might be able to use, which are all grown materials, not timber, but a grown material, natural fiber product that we could start using. We didn't need to be designing for lower body carbon, and like I say, timber, when it's growing, it's taking carbon out of the atmosphere, it's taking CO2 out of the atmosphere and turning that into carbon in the actual timber in the tree. So on average, you might get sort of 1.6 tons of CO2 being stored in every ton of timber. It's about it works out about 700 kilos per cubic meter of timber, if you want to put it in that way. And obviously the processing of that product is also fairly low carbon. So what you end up with in that building is a certain amount of stored carbon that's locking that carbon away for the length of the building. So what we want to make sure is that we keep that timber in use for much longer. And like, I would, I'm talking about timber today, I would look that you use more timber instead of steel or concrete going forward. We've also, when you start looking at how that's processed, there's some good examples of the timber factories actually, reducing their carbon footprints to very much close to zero. VHAG, for example, has got their factory is generating something like 38 gigawatts of renewable energy from the waste from their processing. So that's around 10,000 tons of sawdust and offcuts that are being used for that. So, lots of, and that's covering all their kiln drying, their electricity for, processing. And they actually I think they're a net exporter to the grid as well. We then need to start looking at how we design for optimized service life. And I'll talk about optimized service life here because, not every product will be able to design for extra long life. And we take, for example, a flooring material. Previously, we might have used carpets, but flooring material is not going to be there for 100 years. It may be, but let's take, fashions change. People might want to change the flooring in their house. And if you use a timber flooring, could you design that in like this version here so that it couldn't be, reused, etc. But using carpet, using wooden flooring rather than carpet is obviously going to last longer as well in that situation. Could we look at, our timber windows at the moment? Could we look at extending the life of those in some way through some sort of treatment to make them last longer? Similar way our cladding might only last 15, 20 years at the moment. If you just use a softwood cladding, could we use a different species of timber that's going to last longer? Or again, some sort of modified product that means that product can last a lot longer, maybe 60, even longer than that. And obviously our frame, we need to make sure we design and detail that to ensure that it doesn't get damaged during its life and can last that minimum, say 100, 120 years plus. And that can be done. If you look out there are timber buildings in use at the moment that are over 500 years old. So, this can be done. It's just a matter of making sure that we build these things in the right way. So looking at some of the things we might want to do, we can look at different types of timber. So whether that's a durable softwood, such as, a Western red cedar or larch, which are in these pictures here, or on the right-hand side, some sort of durable hardwood. A lot of people go for oak, but actually what this one here is actually a chestnut. A sweet chestnut looks very similar to oak in the color and the grain, but can be used as produced from a coppiced material. So that tree is continually grown, and we just take parts of it off at each time. So a coppiced production. So could we look at using different types of timber? We've obviously got chemical treatments, and we talk about our copper chromate, CCA, copper chromate arsenic treatments. They're very good. We've used them for the last probably 60, 70 years in timber. The trouble is chemical treatments could limit the future reuse of that timber going forward. We've just finished a project with the Wood Recyclers Association and the National Federation of Demolition Contractors, which showed that some of the timber that's coming out, particularly the smaller section timbers like tiling battens and maybe some stud material, may still be hazardous. May now be hazardous, and we won't be able to reuse that timber in certain buildings going forward. So we just do need to be careful. Excuse me. How we do treat timber to make sure that they are reused. But if we are going to use it, make sure that we're using it in the right place. So don't use a use class 2 outside because it's just not been treated to the right level. There are different use classes, and make sure you know specify the right use class for the right location. So internal, structural timbers, so your floor joist, roof joist, class 2 is okay, but if you're looking at something like a decking or a cladding, you might that's in contact with the ground, you really need to be looking at so cladding that might not be in contact with the ground, use class 3, but something that's in contact with the ground, like a say like decking structure or your fence posts, that would need to be a use class 4. So make sure you specify the right U class for the timber you're using. But we have seen some more modified type timbers coming through over time, and people might have heard of Accoya, but there's also things like Kebony, which are treated with like alcohol in the case of Kebony, and in effect vinegar, so acetylated timber, basically vinegar, which modifies the structure of the timber and it makes it unpalatable to the pests, the insects and the fungi that would usually feed on timber and cause the issues that the rot that we've all seen in timber products. So basically this is basically totally changing and modifying that timber to a different product. And let's say Accoya, for example, will guarantee their product for 50 or 60 years. So we're starting to see that extension in that life of the product. There's also things like thermal modification. You've got the hardwood on the side there, called a product called Brimstone, which is modified UK hardwoods, which wouldn't generally be used for any other purpose. So things like ash and sycamore and poplar are very much underutilized species from the UK, and they're being modified. But they're non-durable species, those ones. So we couldn't normally use them outside for cladding because they'd rot. But by thermally modifying them, we can start to use them outside. Similarly with softwood, this is a thermal wood. Again, this type of softwood, a pine or a spruce, wouldn't be able to use outside without some form of chemical treatment. But by thermally modifying it, again, it means we can use it outside. So that's sort of extending the life, but we could also need to look at utilization and optimizing that service life by increasing the number of uses of that product. So we talked about hoardings, and we've also got things like packaging material, pallets there, which are generally single use. We put a hoarding up and make it out of ply and lots of bits of timber, and then at the end of the job it goes in the skip, and that's not a good use of that product. So looking at different options, so you've got things like Hoard It, which is a reusable system which uses metal supports to hold the plywood, and the plywood doesn't have any fixings going through it, so it means there's no moisture indentation into that plywood, and it can just be stacked up and reused for the next project along with a support system. And pallets, there's a new system coming in at the moment called Loop, which is a pallet pooling system, which means materials will come out on loop pallets, come to the construction site, the materials will be used, and the pallets will be sent back, refurbished, and reused for new products. That alone, the estimates from Loop say that we can cut our timber usage for pallets from around 600,000 cubic meters down to maybe 150,000 cubic meters, with accompanying reductions in carbon footprint and everything else. So some big savings to be made, and then that timber that wouldn't be used for pallets now can maybe go into other construction materials. We need to design for ease of maintenance as well. So that's the next step. So going back to our cladding here. So, sometimes we put cladding up and we want to paint it. But if we can't get to that cladding again, then how do we maintain that cladding going forward if we put that cladding, it's fairly high up on a building? So sometimes the best thing to do is actually not to treat it at all. Brimstone is designed to not be treated at all, and what it does, it fades to a weathered grey within around 12 months, and you can see it on the right there. So it still gives you a life material, and we don't have to touch that again, so you haven't got that maintenance issue going forward. We then need to design for flexibility, deconstruction, and disassembly. So this is key for a circular economy. At the moment, we design stuff and we bolt it together for a single use, and then when we want to take it down, we generally, in the olden days would have been a ball and chain, but we generally now go out with a hydraulic grab on a machine and just pull that building to bits. Now, that's not going to help with the circular economy. We need to build buildings so they can be deconstructed at the end of their life and moved and maybe reassembled somewhere else. So we need to look at different types of joints. So you've got on the left there things like what we call a Sherpa glue lam connections. There's lots of Rotherblast do a similar one where it sort of slots in into a holder actually on the main beam there and holds all that frame together. At the end of life, it can literally just be lifted off. And similarly, you've got this example from cars, which is a floor, and then they've got what they call the Woodlock 5S connection. And in effect, what happens is that wooden floor, engineered wooden floor, in effect folds together and creates a homogeneous flooring system, but at the end of the day, if someone wants to take that up, they can actually just in effect fold that timber back out and move that flooring somewhere else. So, great systems. We are starting to see some modern methods of construction that I'm not too sure about how we're going to recover them at end of life. One of those is things like SIPS panels, for example, where the jury for me is still open on this, where in effect that's 2 sheets of OSB bonded onto an insulated pit panel. It's a great product, really insulating, but how do we recover that at end of life? And we need to start thinking about that. And just to show some examples of where this has been used, you've got the Vitso factory in the UK, which was designed by War Thisserton. And basically, the Vitso create furniture that can be moved and reconfigured, and they wanted a factory that could be done exactly the same. So all of the panels, all the walls in this factory can all be moved around and to divide up the space in different ways. We didn't need to be designing for remanufacture, reuse going forward. So whereas at the moment we might design a building and it might be going to refuse-derived fuel or biomass, or possibly into some sort of open loop recycling, we need to be designing that building so it can be dismantled and reused, or the component parts taken apart so it can be remanufactured, refurbished and reused going forward. So moving them up this reuse hierarchy. Some examples you've got, again, these are from the Netherlands. Huismans have created this house that cranes into position, can be assembled on a site that's only maybe available for a short amount of time, maybe 1 or 2 years. They can put this housing in place. House families or individuals, these are quite small, these houses, maybe more so for individuals, for a short amount of time, but then maybe move them somewhere else when another piece of land becomes available. So, very much a reused item there. And then this example from Australia, where they needed to build a new building because they had very much an urgent demand for a building, but the land they wanted to build it on wasn't available at the time. So they had a spare plot of land on the college that they said, right, okay, we'll build it there, and when this other plot of land becomes available, we'll actually move it. So this building here has been designed to be dismantled and moved to another plot at some point in the future. So we've got some ideas on how we might be able to keep those buildings in use and circular model economy designs, but how about the business models? How do we sell these products into the market going forward? So the thing we need to look at is we've got our source for our raw materials. I call this the 5 R's. They're either reused resources, refurbished, remanufactured, recycled, or renewable. So that's our resource. For the first recycle, we might have 2 options there: closed and open loop cycle. So closed loop means that it's been designed to come back and be recycled within the same system. Open, as it says, it's just designed in the hope that someone else might pick that material up and use it in the future. So obviously the closed loop is the much better option. And if we use that closed option up to refurbish, we might need to think about maintaining ownership of that product as the manufacturer. So we can then get that material back, refurbish it, remanufacture it, and then push it back out into the market. So how might we want to do that? So there's lots of options here on how we might want to keep those products in use. So we've got things like asset management, tracking the assets. So that might be if you own a load of products and you might want to move stuff around your own estate. That might be good for, say, a university. I know use this, and they track all their desks and chairs to make sure they can be moved around. So when they redevelop an area, they know whether they've got furniture that they might have somewhere else that they could reuse for that new developed area. Collaborative consumption is a similar thing, where you might have people in a block or a block of flats or a small community where they share certain tools, maybe lawnmowers or hedge trimmers, because everyone needs them, but they only use them maybe once every now and then. So could they be some sort of collaborative consumption there? But things like service products, where a company can come in and for lighting and sort of boilers, where they might come in and service that on a regular basis, could that be done under a service contract? So we don't buy the product, we just have a service contract with someone, and they come in and they supply the piece of kit and then maintain it going forward. And where it doesn't need to be serviced, do we hire or on a short term, or lease it over a long term, over a defined period, and then return it to that manufacturer at the end of use? So things like that are very much starting to come into thinking now. Or things like incentivized return, where we might reward someone for return at the end of life. In effect, things like a deposit model. So the pallet model, where we talked about earlier on, there's an incentive there to give that pallet back, because you'll get some money back at the end of the day. So choosing the business model will depend on the product and maybe the life. So we've got our products going back in here that we mentioned earlier on, short to long term service life, but we also need to think about our maintenance. How much maintenance does this product need? So flooring might need to be cleaned on a regular basis. Our doors and windows might be serviced, hinges oiled and things like that. So there's a certain amount of element of service in there. But things like cladding, if we don't have to paint it, like we mentioned earlier on, could be very minimal maintenance, and our frame shouldn't need any at all if we've designed it in the right way. So in which case, we can then start to overlay what model might best suit that product. So things like flooring and windows and doors may suit a service type contract. Your cladding might suit a long-term lease, but you're building it because you might be able to replace that after 30 or 60 years. But your frame, you might still purchase that, but there might be an option there that at some point in the future that it can be bought back or reused if you designed it that way. So that's really a very much a whistle-stop tour of the circular economy and how timber might be able to use. So hopefully you've now got a bit of a better understanding of what the circular economy is, but just a few takeaways that we want to instill in you before we have questions is ensure that the circular economy is part of your sustainability agenda. We need to make sure that we're designing the circular economy and not just thinking about carbon, because if we design to circular economy, you are going to reduce your carbon footprint going forward as well. So, make sure that's part of your sustainability agenda. Where you're sourcing timber, make sure that's from a responsible source. So, for example, we mentioned PEFC, FSC, and grown in Britain timber. So, if you are using timber as part of that circular economy, make sure it's responsibly sourced. Incorporate some of those circular economy design principles that we've touched on as we've gone through this course. As far as reuse, resource efficiency, maintenance, etc. And then maybe consider what type of business models you might want to use as part of that. So could you use a service model for if you're putting flooring in, or do you want to see if you can lease certain products for long term rather than having to buy them outright going forward? So thanks very much. Ignore the feedback form there. Howard's got his own feedback form that he's going to cover in a second, but I'll hand over to Howard for some questions, if that's okay.
Yeah, thanks very much, Charles. We have some questions. So Abraham, I wonder if you could please put those up on the screen, the first one. Just be patient while it comes up.
Yeah, no problem.
So take the first one. With Russian and Belarusian timber now out of the market for many in Western world, how will this loss of timber be made up as we move to using more timber?
Yeah, good question. Absolutely great question. Right, so the key products that were coming out of Russia were very much birch plywood. So the very high quality plywood that we might use for things like furniture. They're actually used for Marshall speakers and things like that. So that source is now very much gone. There's very little birch plywood available at the moment. So we need to think about other finished timbers that we might want to use in place of that. It's a difficult one, but you could, where you're using it maybe on a wall as long as it's fixed in place, could you use something that's got a bit more texture to it, like the OSB? For example, that might be something you might want to think about if you want it as a decorative finish. As far as a plywood, if you do need to use a plywood, there aren't many examples. I know the Timber Development UK, which is the timber trade body, is looking at whether there are alternatives out there. There are some good quality plies, but they might not have all the properties that you need for your timber. For example, Birch ply has very good acoustic properties, hence why it's used in Marshall speakers. And there's a bit of debate whether there is another plywood that they could use for that. So it's really just, you will need to discuss with your suppliers if there is any other source. As far as the quantities, it's quite a small percentage for the UK. Like I say, it was about 500,000 cubic meters from that 16 million that we import. But other parts of Europe rely on Russia and Belarusian timber a lot more than us for things like pallet wood and things like tiling battens and stuff like that. So that will need to be made up from other areas. Now there is, there is probably just about enough supply. They're talking about increasing the harvest in Europe to see if they can take actually more timber out of the forest. But obviously it goes back to that fine balance that we've got at the moment with timber. So we do need to look at using alternatives other than timber. So going back to the example we had around the eye joists, in the past we might have used an 8x2 floor joist. And that has got a fair bit of timber in it. Actually, if you use an eye joist, you're probably using maybe a third of the timber by using an eye joist, half to a third of the timber. So we're becoming much more efficient with the material. So if we all moved over to using eye joists from solid timber, they are more expensive, unfortunately, but that would allow making sure there would be enough timber there. So there are some options that we can do, but there is going to be an impact, unfortunately.
Okay, thanks, Charles. Let's have the next one, please, Abraham. Geoengineer interested in expanding use of driven timber piles. What can I do to satisfy clients, technical review bodies on durability over 50 to 100 years?
I think that's very much outside my technical ability. That one, I think we very much need to be looking at the universities there and people like the BRE to see if they can do some extended durability tests for you. I know a good contact for that, if you want to speak to someone, is a guy called Ed Sutty. He's the timber and materials director at the Building Research Establishment. So if you contact them, I know he has been doing a study on treated timbers at the moment. I'm not sure if that's finished now. I haven't seen the results of that, but they was doing an accelerated study on durability of treated timber type species, treated to different levels, and see what is the minimum treatment content. So very much a lot of experience in that, and they'd probably be able to help you satisfy that requirement. So so contact someone like the BRE or BM Chard or someone like that, and they'd be able to come up with a way of being able to test that and confirm that durability for you.
Okay, we've got another buried one here, I think. Can I consider buried timber which isn't recovered or expected to suffer from rot as a long-term carbon sequestration?
I'm sorry, well, it's difficult to know what they mean by buried timber, which isn't recovered or expected to suffer from rot. The way they treat timber is that, in effect, yes, it is carbon stored, and it will remain in that timber for the duration. But I think, if I remember right, the standards after 100 years, it assumes that timber is being returned to nature, to the atmosphere. So you will have to, if you're doing a whole life carbon calculation, you will still need to allow for that timber that the carbon in that timber to be emitted to atmosphere at some point in that carbon calculation. So, if that's where you're coming from, because it's different to know what the question is. If you're designing a building and expect to say, right, we're going to use this bit of timber for 10 years and then we're going to bury it for 100 years to try and see if you can get a carbon benefit from it, that's not going to work, I'm afraid, because you still need to add in that carbon that's emitted at the end of life at some point in that calculation, I'm afraid. But
okay.
But it is storing the carbon, so that you can say that it is storing carbon for that period of time. It's not being burned and going to atmosphere.
Okay, Charles, thanks for that. Okay, another one. Many recycling centres do not take pressure treated metallized wood, i.e. decking. Does this mean much wood is not entering this circular economy?
You're right, and this is down to the issues that we've got at the moment with the testing now. There is continued testing going on with these types of materials, so decking and stuff like that, because the testing that has been done to date actually demonstrated that these were not hazardous materials, so they could actually be reused. And recycled into things like panel boards. So, but that work is still going on at the moment to demonstrate that. And at the moment, individual companies will have to make sure that they test the product to make sure it's not hazardous before they can accept it. So it does mean that some timber isn't going into the circular economy at the moment, but the key that we need to think about is how do we design for future? And this goes back to what we're saying about using treated timbers. Should we actually continue to use chemically treated timbers that, at the moment there's a threshold level of hazardousness that's allowed, and anything below that threshold we can reuse, and anything above it is classed as hazardous timber. That threshold could change at any time and could come down. And it means that timber that's classed as non-hazardous now that's going into buildings, because all the timber going into buildings at the moment is classed as non-hazardous, but at some point that threshold could come down, and it could mean that timber then becomes hazardous when it comes out at the end of its life. So we do need to be looking at things like detailing, different types of thermal modification. In some cases, we're not going to get away from treatments, chemical treatments. So internal structure, we're probably going to have to carry on, I'm afraid, with tannalized type timbers and probably decking as well. But decking, there are alternatives there. Could you use a thermally modified timber externally? Could you use something like a coir or Kebony type timber that's been modified rather than chemically treated? So there are alternatives there. Maybe that's what we need to be looking at for those projects rather than tannalized chemically treated timbers.
And I think that leads on to the next and last question. Where can we get advice on specifying the appropriate chemical treatment of timber?
Okay, the best source for information there is the Wood Protection Association, so the WPA. So if you go to their website, they've got lots of information on there about what use class your timber should be treated to. So use class 2, use class 3, use class 4. So which timbers fit into that category. So yeah, Wood Protection Association, go to their website.
Okay, thanks very much. Okay, thanks very much, Charles. What we're going to do now is ask if you kind of give your feedback on today's session. So we're going to put up the questions. Again, if you like to go to Slido polls, you'll find the questions already there. So the first question we're going to ask is if you could rate, please, 1 to 10 on the stars, the session held my interest. The next question, please. I was encouraged to participate. The content was pertinent and relevant to my place of work. Next question, what I learned will help me in my role and work. And next question, I will recommend others who did not attend this session to watch the recording. And there are 2 open questions. So if you could take the time here, how could this session be improved in future? And the second open question, are there any other comments you'd like to add? So if you could kindly give us feedback on that, you can continue to do that. Okay, what we'll now do is we'll put up today's CPD. So if you'd like to get a certificate for CPD today, you can do that by going along to MyProPass, and there are the details. And lastly, do we have yet next week, we've got funding modular housing with Katie Saunders. So if you'd be interested in registering for that, you can do so now by going to leadersmeets.com. I don't see any more questions come up for Charles, but I'm just checking. No, I cannot see any more. So Charles, many thanks for kindly educating us on the circular economy in relation to timber.
Pleasure.
And let's hope it grows. I mean, yeah. I mean, I know it's just a bit late for a question, but chipboard, what's the sort of content of new wood in chipboard and old wood?
It's a little bit difficult, that one, because I think recycled content, I believe, is around 30%, but then
Right.
a lot of the remainder is what we call co-product. So and it's a bit difficult to say whether that's been chipped from, so that's 70% that's left. It might be stuff that's come from sawmills, and all the chippings, obviously, from that sawmill process could form a big percentage of it. But it could be freshly chipped material that's for the chipboard as well. So there's a big percentage of that, what we call co-product, which in effect is it's a circular product, because we're using that chip and using it in another product.
Yeah.
But the actual recycled content coming from used consumer wood is quite low. It could be a lot higher, I think.
And where does chipwood fit in the circular economy? Can chipboard be used again, like MDF? Can that go round the cycle again?
Well, yes, there's some good stuff going on in that, actually. So chipboard we use a lot for flooring, so it can lock up carbon for a long, long time. So most new houses will have chipboard floors, and they will stay down for the duration of that house. So it could be locking up carbon for 100 years. And when they come out, and MDF similarly. But there's a good project. MDF was always a bit difficult to recycle because of the resins in it. But there's a project going on at the moment. There's a demonstrator that's just happening now, where they're looking to recycle MDF into insulation, so wood fibre insulation for loose fill for modular housing. So ties in nicely with your presentation next week on modular housing. There could be recycled MDF that could go into the walls and be used for that.
I know cost is a factor, but UVPC windows are still being used on all housing developments. Now, I know wood's more expensive, but it lasts longer than UVPC.
Yeah, absolutely.
But even though UVPC is recyclable, it's still a problem, isn't it, in recycling? It's still a nasty industry.
Yeah, I think it's the PVCs. They're obviously. I'm not an expert in UPVC windows, but they had a lot of different chemicals in the plastics in the early days, and a lot of them that's now come out. But obviously, it's known whether that chemical is in your windows or not, so it is difficult to recycle them. People think they're going to last a long time, but as you say, actually timber windows, especially you start looking at the new modified timbers like a Koya, will last 60 years, whereas UPVC, some people are saying they might only last 20 or 30 years. So so timber, modified timber window will last twice as long. Yeah,
but they do cost twice as much, don't they, at the moment?
They do cost a lot more, yeah. But we need to look at that as a circular economy and look at things as a whole life cost, not just a capital cost. And that's key to a lot of the stuff we need to do for carbon and circular economy, is looking at that whole life cost and environmental impact, as well as purely just focusing on that capital cost and being blinkered about the rest. So,
thanks very much. We've kept you a minute longer.
No problem.
Thanks to everyone. And do have a great weekend, and we look forward to seeing you next week. And thanks once again, Charles. You have a good weekend.
Thanks, everyone. Good to see you.